Hi guys, I hope you had a really nice spring break. Most of you guys will be watching this the next day after spring break, so please make sure you have something to write with, paper, pencil, all that kind of stuff. We are going to be doing the second part of Unit 3, so we're still talking about quadratics, the parabolas. We're going to be factoring here and there. We're going to be drawing the pictures and all that kind of stuff. Now we're just going to show you some other things involving those quadratics. So I'm calling this Unit 3 Part 2, and then we're just continuing. So Day 9 notes. The topic for today is a little bit review. The topic is simplifying square roots. So before we get kind of into the new stuff, let's go ahead and do a warm-up on factoring. So just to recap, whenever you want to factor, so I have this trinomial here, I want to find or look for a GCF. I noticed that I can take out a 2. So I'm going to take out a 2 from every term, and I'm going to be left with x squared plus 6x minus 27. And then I want to see what multiplies to 27 and adds to 6. So I go through this and I list my numbers. Remember, we did this on the side, 27 and 1, 9 and 3. I think those are my only choices. I think if I use the 9 and the 3 and I do a positive 9, negative 3, I can use that combination. Don't forget the 2 out in the front here, you need to drop it down. I put a positive 9 in the parentheses and I put a negative 3 in the parentheses. And that would be my factored form. Okay, next one. This has 2 terms, so this looks like a difference of squares type problem. Remember, with difference of squares, you want to make sure that they have a minus sign in between them, and then you just want to double check that the numbers are perfect squares. So the square root of 1 is 1. That's a perfect square, so that looks good. So you split this up into your 2 parentheses. The 1's go in there, and remember, this looks exactly the same right now. One of them has a plus and one of them has a minus. And then that's completely factored for this one. Okay, the one next to it, problem C, I look for a GCF. I don't see a GCF that can come out of every piece, so I'm going to be stuck with what multiplies to 10 and adds to 17. And let's just list some of our options here. I have 10 and 1, 5 and 2, and that's really my choices. So I'm going to make my factors. Remember, you have to be very careful because you need to split up this 3x squared. So if I split up 3x squared, that's going to be 3x and 1x. So when I split that up, I'm going to separate it like this. And again, you have to be also very careful on where you put the numbers. So you have to make a decision. Should you use the 10 and the 1, or should you use the 5 and the 2? And again, you might need a pencil. You might need to write this out and try it a couple times. It's trial and error. I think I'm going to go with using the 5 and the 2, and I'm going to put the 5 in the back and the 2 in the front. And I remember I used orange pen, and I checked the middle by multiplying, and I checked the outside by multiplying, and I try to get those to 17. So if I added both of those, and they were both plus signs, then it would work, and I factored it correctly. Okay, so again, that's just a kind of a recap on factoring very quickly there. So then a little more of a recap, it says, what are perfect squares? I remember we did this a while back, so let's go ahead and just list them out. The square root of 1 is technically a perfect square. That's 1. The square root of 4 is a perfect, there we go, is a perfect square. That's 2. The square root of 9 is a perfect square. That's 3. The square root of 16 is a perfect square. That's just 4. The square root of 25 is a perfect square. That's 5. The square root of 36 is a perfect square. That's 6. The square root of 49 is a perfect square. That's 7. Square root of 64 is a perfect square. That's 8. The square root of 81, let's redo that. 81 is a perfect square. That's 9. The square root of 100 is a perfect square. That's 10. And we did a few more. The square root of 121 is 11. And the square root of 144 is 12. And I remember we broke that down a little bit and talked about that before spring break. But you really want to know those. You want to be familiar with those, because if you look right away at this first problem, it says, what is the square root of 4? I'm going to teach you a process. But if you just know these, what is the square root of 4? Well, look at this. I highlighted it yellow. Well, the square root of 4, I don't even have to do any work. I just know, oh, okay, it's a perfect square. The answer is 2, and that one's done. So if you can recognize those, it makes your process in life a whole lot easier. Look at number 2, square root of 50. If you look at your perfect squares, is that on there? No, it's not. So then this is where I'm going to show you that process. And the process that we're going to do is by making a factor tree. And you've done this at some point in Algebra 1. I'm not sure exactly when, but you did this at some point. You made some factor trees. So I'm going to make a factor tree. And what I'm going to do is I'm going to think of what two numbers multiply to 50. And for me, the first thing I think of is 5 and 10. And then I want to keep breaking them down as low as they can go. Okay? I'm going to look at the 5. Does two numbers multiply to 5? The only thing I can think of is 1 times 5. And if you're at that point, that's not going to help you. So then you leave the 5 alone. I'm going to look at the 10. What two numbers multiply to 10? 5 times 2. So that actually breaks apart. Again, look at the 5. 5 times 1 gets me 5. Well, I don't want that. And then look at the 2. 2 times 1 gets me 2. That doesn't help me at all. So I branch this off until as I can go as far as possible. Once you branch this off, I now look for my pairs. And I'm going to circle them. I look for my pairs, my partners. So those two 5s are a match. I circle those. And I'm also going to underline my leftovers. So that 2 is a leftover. So when I write my final answer, the pair of 5s come to the outside, and the leftover 2 stays underneath the root. And that is how you would write your final answer. Okay, so let's look at the next one. Square root of 72. It is not a perfect square, so I'm going to start to branch this. What multiplies to 72? The first thing I think of is 36 times 2. Now let's branch off of 36. What multiplies to 36? Well, the first thing I think of is 6 times 6. What multiplies to 6? 3 times 2. And I can put that for both of them. Okay, can I break down 3 anymore? No. Can I break down 2 anymore? No. And okay, so I went as far as I can go, all my branches. I'm going to circle my pairs. So I have a 2 there that match. And let's do a little swerve here. I have 3s that match, and then be careful, I have a leftover 2 up at the top. So when I go to write my answer here, the circled pair of 2s come to the outside, and the 3s come to the outside. You multiply those, and the leftover 2 stays underneath. So 2 times 3 is 6, and then the 2 stays underneath. So my answer is 6 root 2. Okay, let's do a few more. They're starting to get a little bit more complicated. Number 4, the square root of 24 over the square root of 12. The first thing, and maybe the easiest thing to do, is see if these can reduce. So think about just like a normal fraction. Can 24 over 12 reduce? Hopefully you can say yes. I can go ahead and think about dividing both of these by 12. So how many times does 12 go into 24? 2 times. How many times does 12 go into 12? 1 time. And that just made my numbers a heck of a lot smaller. So now I'm going to think about branching these. So I'm going to treat them separately, do one at a time. So I'm going to do this on the top here. What multiplies to 2? 2 times 1. That doesn't get me anywhere. So the top is what it is. What is the square root of 1? That's a perfect square. The square root of 1, I'm going to put a little star by it. That's a perfect square. So the root 2 stays on the top, but the bottom is a perfect square, and it's just a 1. You technically don't need that 1 on the bottom, and you could just write your answer as square root of 2. Okay, let's look at the next one. It's a big root. The whole root, and then there's a fraction inside there. If you don't really like it like that and you want to separate it, you can. You can do square root of 25 on the top, kind of its separate thing, and square root of 49 on the bottom. Again, you just split it up into 2 different pieces. The reason I wrote it like this is because you should recognize these. These are 2 that you should know. I'm going to put little stars next to them because these are perfect squares, both of them. The square root of 25, you should know that, is just 5. The square root of 49, again, you should know that, that's 7. And then that's it. I recognize the square or the perfect square, so then I'm done. Number 6, the square root of 75, that is not a perfect square, so let's start to branch it. So what multiplies to 75? The first thing I think of is 5 times 15. That's just what came to my mind. I try to branch off of the 5. The only thing that multiplies to 5 is 5 times 1. That doesn't help me. The only thing that multiplies, now let's do 15. The only thing that multiplies to 15 is 5 times 3, and then I'm stuck there. So I'm going to circle my pairs, my matches, and I'm going to underline the leftover piece. I always do that just so I remember. The circled match comes to the outside, the leftover 3 stays underneath, and that would be my answer. Okay? The next little part here, it says rationalizing the denominator. So when you want to rationalize, that means that there is a root in the denominator, and you cannot have a square root in the bottom of a fraction. Almost like think like it's illegal. You cannot have that. We do not want that. We try to get rid of it. So, see this first problem? 1 over root 3. I'm going to go ahead and get rid of that root 3 on the bottom. So I'm going to multiply by the problem. The problem is root 3. So I'm going to multiply the top and the bottom by it. And then I'm going to multiply the top, because that's how I multiply fractions. Multiply along the top. 1 times root 3 is just 1 root 3. And then I multiply along the bottom. On the bottom, I have root 3 times root 3. That's going to give me, multiply 3 times 3. That's going to give me 9. Then I see if I can break this down, simplify it, anything like that. So if I try to break this down, let's go ahead and do, I don't need the 1 in the front. The square root of 3, if you want to try, it doesn't break down. The square root of 9 is something you should know. You should recognize that and be like, oh, that's a perfect square. That's just going to give me the number 3. And you should know that. And then that would be my final answer. And this is okay because there is not a root in the denominator. Let's do the next one. Number 8. I want to get rid of square root of 28. If I want to get rid of the square root of 28, I'm going to multiply top and bottom by the square root of 28, by the problem. So then I'm going to go ahead and multiply the top, that's the yellow part, 1 times the square root of 28, that's 1 times root 28, and then on the bottom, okay, on the bottom, I'm going to show you a little trick. Let's write it down here in purple. I have square root of 28 times the square root of 28. Well, the 28 times 28 is a gigantic number, so here's my little trick. If you have the square root of 28 times the square root of 28, it's always going to end up being whatever number is underneath there. And I'll give you some more examples, but I'm just sticking with that one for right now. So instead of doing all the factor tree and kind of going the long route, you can just know if those match, then you can just go ahead and take the inside. Okay, and then I'm going to even show you a little bit more because I notice on the top of this, I can branch off what multiplies to 28. Lots of options. I'm thinking 2 and 14. And then 14 can break down to 2 and 7. And the reason I'm doing this is because there I have a match, a pair, and I have a leftover. And I can rewrite this as the 2 on the outside, the 7 on the inside, and it's over the normal 28. And the reason I want to point this out to you is because now I can reduce. The 2's on top, the 28's on the bottom, I can reduce that. I can almost like divide both of these by 2. 2 goes into 2 one time, and then I have root 7. 2 goes into 28 14 times, and now it's completely done. I'm going to go back down here to the purple part for a moment. I'm just going to throw out some more examples. If I had the square root of 3 times the square root of 3, all that's going to give me is 3 times 3 is square root of 9, but if I use my shortcut, it's just going to be 3. What about square root of 15 times the square root of 15? Again, same thing, they match, it's just going to be 15. Square root of And you could keep going and going, and I'm just going to keep making up problems.